You might have heard that this function right over here, cosine of x, is actually an even function, meaning that f of x is equal to f of negative x. So in this case, cosine of x is equal to cosine of negative x. So for example, let's say if I have cosine of, let's say, I don't know, 3x plus 4. Well, this is just going to be equal to cosine of negative times 3x plus 4. So this negative sign up in front is 4. Right, so in this case, this x right over here is 3x plus 4. And then cosine of negative x, so it's just this x right over here on the inside multiplied by this negative sign. Now, why is this true? You might be saying, okay, a function is even when it's symmetrical about the y-axis. So take a look at this function, f of x is equal to x squared. Notice how it's completely symmetrical about the y-axis, right? So if we were to flip this side onto the other side, it would match on perfectly. And if I were to flip the other side, right, and I flipped it onto this side, well, it would also reflect on perfectly. So notice how the graph of f of x is equal to cosine x, perfectly symmetrical about this y-axis. However, why is that though? I want y'all to get like an intuitive understanding of this. So let's use the unit circle. So let's say that if we create an angle x, right, on the unit circle. So what I'm going to do is I'm just going to draw down an altitude. This creates a 90-degree angle. And from your unit circle properties, you might remember that this point right over here is cosine of x, comma, sine of x. So it's going to be cosine of the angle that you created, comma, sine of the angle you created, where cosine of x represents the x value, right? Cosine of x represents the x value, and sine of x represents the y value. Now take a look at what happens when I create an angle that's negative x. So when I create an angle that's negative x, it's going to look something like this. This angle right over here I created is negative x. In case you're confused about kind of what happened there, like imagine if I created a 30-degree angle, right? It would look something like this. If I created a negative 30-degree angle, it would look something like this. Because when you're creating a positive angle, it goes counterclockwise. But when I create a negative angle, it goes clockwise. So that's kind of what's happening here. So I'm creating a negative this angle, right? Negative this angle. And, in this case, it's going clockwise. So it's going to hit the unit circle at this point right over here. So this angle right over here is going to hit the unit circle at this point. And this point right over here, we can label this as cosine of negative x, comma, sine of negative x. Right, because any point on the unit circle is cosine of x, comma, sine of x, right? When you create an angle, it's cosine of that angle, comma, sine of that angle we created. So if I create a negative angle, negative x angle, the coordinate of that point, and the coordinate of this point right over here, is just going to be cosine of negative x, so cosine of the angle that we created, comma, sine of the angle that we created, which is negative x in this case. So, all we did was just kind of change the x to negative x because that's the angle we're dealing with. Now, we know that cosine of x represents the x value. You can think about this as the x value of our triangle right over here. And notice how the x value is the same. Notice how the x value is the same for both of these triangles, right? For both of these triangles, when I create an x angle and this negative x angle, my x values are the same. You can think about what's happening right over here as I'm taking this triangle when I create an x degree angle, and I'm sort of reflecting it. I'm reflecting it about this line. So, and then it creates this other triangle, right? And when I reflect this triangle on to the other side, well, my x value doesn't change, right? My x value does not change. However, what does change is our y value. You can clearly see that our y values are different. But our x values are the exact same thing. So this is why cosine of x is an even function. Because whether you create, let's say, an angle x or an angle negative x, well, guess what? when you create a triangle here, well, it's all gonna, the x values are all gonna be at like the same point. It's literally just gonna be the exact same triangle as we had with creating the x angle, except you just reflect it about the x-axis to create this negative x angle, and only the y value changes. Now, the actual proof for cosine of x is equal to cosine of negative x, the actual like algebraic proof, for this, we got to learn a couple of properties, and I'll do them in kind of the next videos. But basically, let's actually just do the algebraic proof right now, because why not? Let's say we want to kind of find out if this is true. So what we do is we can use a property that says that cosine of x is equal to sine of pi over 2 minus x. Let's say if I have this triangle right over here, I have this 90 degree angle, or this pi over 2 degree angle. I have this angle x, and I have this angle 90 minus x. Now you might be saying, where do I get this 90 minus x from? Well, think about it. All the angles in a right triangle have to add up to 180, right? All the angles in any triangle have to add up to 180. So if I have this 90 degree angle plus this x degree angle plus this 90 minus x degree angle, well, guess what? I get 180 because the x's just cancel out. So everything works out. Now let's say I want to take cosine of this angle. What am I going to get? Cosine is equal to adjacent over hypotenuse. So in this case, our adjacent side is going to be this side labeled A, and our hypotenuse is going to be this side labeled C. So it's going to be A over C in this case. Now what happens when I take sine of 90 minus x? What do I get? So what happens if I take sine of this angle? Well, sine of 90 minus x, well, it's going to be the opposite side. So it's going to be A over the hypotenuse, which is going to be C. Notice how the two sides are equal, right? Notice how our values are equal, meaning that these two things have to be equal to each other. The reason why is because, think about it. So let me just now the adjacent side for this is A, right? So for this angle x, the adjacent side is A. Now for this angle 90 minus x, the opposite side is A also. So because the opposite side of 90 minus x is the same side as the adjacent side for the angle x, well, that means that cosine of x and the sine of pi over 2 minus x has to be equal to each other, because the adjacent side for one angle is the same as the opposite side for this other angle, right? And because for cosine of x and sine of x, you have opposite over hypotenuse and you have adjacent over hypotenuse. So if the opposite side and the adjacent side are equal to each other, well then, the hypotenuse has to be equal to each other, so everything works out there. So I can actually rewrite this. So knowing this formula right over here, I can rewrite this as, so I can say that cosine of negative x is equal to sine of pi over 2 minus negative x. Right, because in this case, if I have a negative x here, I'm just going to replace this x with a negative x, right? So in this case, a negative x here, I just replace this x with a negative x. And this is the same thing as sine of pi over 2 plus x equals cosine of negative x. Now this formula, I'm not going to prove because it's like a long proof. But basically, if you have sine of a plus b, this is going to be equal to sine of a times cosine of b plus sine of b times cosine of a. So you kind of do like a swap, So in this case, I can rewrite this as, so this is going to be sine of a. So if we let a equal pi over 2 and b equal x, it's going to be sine of pi over 2 times cosine of x plus sine of b, in this case, which is x. So cosine of b is x times cosine of a. So cosine of pi over 2. Okay. Times cosine of pi over 2. Now, sine of pi over 2 is equal to 1. And you can do this using your unit circle, but sine of pi over 2 is equal to 1. Cosine of pi over 2 is equal to 0. So 0 times sine of x is equal to just cosine of x. And guess what? Cosine, we just got that cosine of negative x is equal to cosine of x. That's the only thing that remains from this equation. So that's kind of how we prove it, right? All of this right over here can be simplified to just cosine of x, and we originally stated that cosine of negative x is equal to sine of whatever this is. So if these two things are equal to each other, well, these two things have to be equal to each other, right? And there we go. Now this diagram can also explain why sine of x is an odd function. And when a function is odd, that just means that, in this case, sine of negative x is equal to negative sine of x. So all this means is that f of negative x is equal to negative f of x. That's what an odd function is. And if you sort of look at things graphically, if you can take a function, you flip it around the x-axis and then the y-axis, or you can do it in the another order, or you can do the y-axis first, then the x-axis. Either way, if you reflect, if the function can be reflected about the x and the y-axis, well, then it's an odd function of x. You can kind of see kind of the same pattern. I take this part, I flip it around, then I flip it again, and it's going to map onto itself. Let's visualize this using the unit circle. So let's say in this case, let's make this simple. So let's say in this case, our sine of x value is equal to radical 2 over 2. So in this case, let's just say my sine of x value, so this value right over here is radical 2 over 2. Well then, this value right over here, sine of negative x, is going to be equal to negative radical 2 over 2. So if my sine of x value is equal to radical 2 over 2, right? So if this value right over here is equal to radical 2 over 2, then sine of negative x is going to be equal to negative radical 2 over 2, because we're going below the x-axis. Remember, our y value, sine of x represents our y value, right? And in this case, our y value is positive right over here, and then it's negative down here. So for this part right over here, I'm going radical 2 over 2 units up, right? But in our other triangle, when we're creating this negative x degree angle, we're going radical 2 over 2 units down. So it's going to be negative radical 2 over 2, right? Sine of negative x is going to be negative radical 2 over 2. And if I multiply both sides by negative 1, well, I just get that negative sine of x is equal to negative radical 2 over 2. But we just said that sine of negative x is equal to negative radical 2 over 2. So we just said that sine of negative x is equal to negative radical 2 over 2. So that means that these two things have to be equal to each other. All right. So this is why sine of x is an odd function. Because if you take a look at the triangles that we've created with this x degree angle and this negative x degree angle, notice how the y values are the same length, except that one is positive and one is negative. So if I just take this positive sign and I multiply this by negative 1, I'm just going to get that negative value that I had with this negative x degree angle. That's basically what we're doing. So in this case, if I multiply my positive radical 2 over 2, which is sine of x, by negative 1, I get negative radical 2 over 2, which is what we had right over here for sine of negative x, right? Because we're going the same distance downwards as we are going upwards. Now let's actually prove algebraically that sine of negative x is equal to negative sine of x. Let's actually prove this. So sine of negative x, I can rewrite this as sine of 0 minus x. All right. Now notice how it's very similar to this form right over here. It's very similar to the sine of a plus b, and then all of this. And it turns out there's actually a formula for when you have sine of one thing minus another thing. This is actually equal to literally the exact same thing we have here, except there's a negative sign. So it's going to be sine of a times cosine of b, and then the only difference is this is going to be minus sine of b times cosine of a. So we are going to have sine of a, sine of 0, right? We let this be equal to a, we let this be equal to b. So sine of a times cosine of b minus sine of b. So sine of b, that's going to be sine of x, times cosine of a. Now, sine of 0, let's just deal with this. Sine of 0 is equal to 0. And 0 times whatever this is just going to be 0, so that all just cancels out. Cosine of 0 is equal to 1. So this all is the same thing as negative sine of x times 1, which is just negative sine of x. And guess what? We just proved that sine of negative x is equal to negative sine of x. Using, in this case, this is kind of like an angle difference formula. So yeah, this is kind of like an algebraic proof for it. So, in addition to learning why cosine is even and sine is odd, you also learned 2 new formulas for angle sum and angle differences for sine. How cool is that?